Have you ever encountered a machine learning model that seems incredibly intelligent on the data it was trained on, only to stumble when faced with new, unfamiliar examples? This common problem is called overfitting, and it occurs when a model learns the training data too well, including its noise and specific patterns, rather than the underlying general relationships. Inverted dropout is a powerful regularization technique specifically designed to combat this overfitting. It prevents a model from becoming overly reliant on any single neuron or specific set of connections by randomly deactivating a subset of neurons during each training step. Crucially, it then scales the activations of the remaining active neurons to maintain the expected output magnitude. The core mechanism of inverted dropout lies in its twofold approach. First, by temporarily disabling a random fraction of neurons, say 50%, at each training iteration, it forces the network to develop more robust and redundant representations. Each neuron cannot depend on the presence of another, preventing complex co-adaptations. Second, the inverted part refers to the scaling of the active neurons. If we drop out 50% of neurons, the remaining active neurons' outputs are multiplied by 2. This scaling ensures that the total sum of activations before and after dropout remains approximately the same, preventing a sudden drop in the network's overall signal strength. Practically, implementing inverted dropout means applying this random deactivation and scaling only during the training phase. When your model is deployed for inference, no neurons are dropped, and no scaling is applied. This simplifies the prediction process significantly, as the model's weights have already been implicitly adjusted during training to account for the absence of dropout at test time. The network effectively learns an ensemble of many possible smaller networks. This elegant method stands out because it allows for a more consistent expected output scale between training and inference, which simplifies the model architecture and reduces the need for additional scaling layers after training. It's like training a team where every player occasionally sits out, making each individual player more versatile and ensuring the team can perform well regardless of who is on the field. Ultimately, inverted dropout is an essential tool in your machine learning toolkit for building models that generalize effectively. By promoting a distributed and robust learning process, it helps your models move beyond memorization, allowing them to make accurate predictions on data they have never seen before, which is the true measure of a model's intelligence.